Okay, good evening and hello again to Michael.
Hello.
Uh, Thanks for joining, Michael.
Oh, it looks like we just lost your feed there.
Often that the tutors,
Okay,
but I
I
think
could
there's
hear.
approximately 2 weeks left for the 2 weeks left for the second set of lectures, mentored quizzes to be completed. The D-date is, I think, the 11th of March at midnight Eastern time. So please try and keep up to date with the mentored quizzes. Okay, Michael, am I still okay? Can you hear me okay?
I can. You dropped out briefly, but you're back. Yeah.
Okay, right. So good evening or good morning to you all. Good evening from here in South Africa. Today we're going to chat about the mash mixer, and if you are having conversion difficulties in your mash mixer, what could be the possible causes? But before we get into what the possible causes are, I'd just like briefly to touch on one question. What is the main action that is happening in the mash mixer? What's happening in the mash mixer? Michael, you want to? Hello?
Sorry, I was muted. I just entered. Yeah, the conversion of starches to fermentable sugars through enzyme action.
Absolutely. So you've got your starch, and you've now going to convert them into fermentable sugars. And what? How does that occur? What in the malt converts the starches into fermentable sugars?
The enzymes, beta and alpha and beta amylase primarily. I think there are a few others. That's
okay. So right. So you've got your main actions are your alpha and beta amylase. Okay. So we've established you've got your mash mixer, and you're converting your starch into fermentable sugars, mainly using, okay, you've got other enzymes that if you go in at different temperatures could work, do other things in the mash mixer. But okay, so what does the brewer control in the mash mixer? What does he actually control? There's a couple of things that get controlled.
Yeah, the temperature and pH.
Absolutely.
I suppose the temperature mostly, I guess, to favor which of the enzymes are favored.
Okay, so the first thing we've got, the brewer is controlling the temperature. Okay, anything else, Michael?
pH, I guess.
The brewer is controlling the pH. You're absolutely quite correct.
And minerals, I guess this is, I mean, I've kind of known about the first two forever, but yeah, minerals, I guess, have quite a lot to do with it as well.
Okay, yeah, remember we chatted briefly last week, calcium content.
Yep.
And remember we said calcium is important, apart from being influencing pH control, on protecting giving your alpha amylase some protection. So, okay, so we've established.
Heat, yes.
Yeah. So we've established temperature. We have established pH. What else is the brewer controlling in the mash mixer? What do you stick into the mash mixer? You've got two things.
Aside from temperature and
what ingredients? Sorry, ingredients.
Ingredients. Oh.
Yeah, what do you put into the mash mixer?
Acid.
No, okay, you can put acid if you want.
You have to adjust the pH. Well,
you put malt.
Okay.
You put malt, and
okay. How about water?
Molten water. Big things. Huge things. That's it. You're putting malt and you're putting water. So do you actually control malt and water in any way?
In terms of the thickness? the
Absolutely. Yep.
stiffness. Yep.
Absolutely. So we
Yeah.
call that liquor to grist ratio.
Okay.
Liquor to grist. And liquor to grist ratio also has a huge impact on the action of enzymes in the mash mixer.
Right. So that handout saying it's thicker mashes tend to protect the enzymes better.
Yep. But it also says with a thicker mash, if you go too thick, you lose extract. I'm sure it says that. So you know you've
Right.
got to get you've got to get the right liquor to grist ratio, and we for lagers, and I just quite forget what the exact what they stipulated in the lecture, but for lagers we used to look at about you see we spoke in hectoliters, about 3.2 to 3.4 hectoliters of water per 100 kilograms. That was sort of the ideal ratio of liquor to grist. Okay, so, but we've established we control liquor to grist as well. So we've got three things so far that we are controlling. So we've got liquor to grist, we've got pH, and we've got temperature. What is in that mash mixer? There's a You've got your mash mixer. What keeps everything in suspension?
I'm not sure when you say suspension. I mean, there's physically there's a grill in the bottom, perforated grill, and there's rakes that sort of
No,
keep
I'm
things
talking
blended.
a mash, not a mash tub. I'm talking the mash mixer now.
I'm not sure then. I
You've
guess
got
this
a,
is.
you've got an agitator.
Yeah, I've never seen
Okay.
one or used one, so I'm.
Okay. So in your mash mixer, okay, you have an agitator, and the speed and the actual shape of the agitator is very important. It's quite important. So you get an even mixing of the actual water and grist in the mash mixer, but you don't want to chop up you don't want to cause oxidation of the mash. You don't want to damage the husk if especially you've got a lauter ton, because that makes your tortilla. So the agitator speed and design is also very okay, but that's more for information and less. Okay, so now let's have a look at. Okay, so we've established we've got four possible things that could be causing this issue of the conversion difficulties in the mash mixer. Right. So the first one we spoke about, I think we said temperature. What controls the temperature, Michael?
In the
How do
mash
you
mixer?
in the mash mixer? If you've got steam jackets in your mash mixer, don't
Yeah,
forget.
I was going to say, presumably it's steam jacketed. Again, this is kind of beyond my level of
Okay.
expertise. I
Okay. Well,
don't know
I'm
really
going to help you.
but steam
You've got it.
jacketing, direct heated, fired.
Yeah, well, it's normally steam jacketed, and you've got a temperature probe. So in your mash mixer, you've got a temperature probe. But so that temperature probe, if you mash in at say 63, 64, it's showing 63, 64. But what do you have to check on that temperature probe?
I'm not sure.
You've got to check that
It's
it's accurate.
accuracy. Yeah. Okay.
Yep.
Yep.
So
Right.
you need a
benchmark.
On a set basis to actually check that probe is actually correct. So then that it's actually accurate. So let's establish we check the probe is correct. So we're quite sure that the temperature probe is correct. Then we spoke about pH. How do you measure pH?
From what I've just learned, it's the actual final grist, the pH of the water is important, but what it boils down to is the actual pH of the grist in the, when it's all done. So I guess you have to test the pH then, and I guess mix in acid if you have to correct, or alkali
Yep.
into the
Yeah,
batch. Wow.
Yeah, we've established that pH, but okay, so you actually measure your pH with an actual pH meter.
Correct, yeah.
So that pH meter needs to be calibrated every time it's used, because, okay, let me ask this question. What is the ideal mash pH? I don't know if you've been through that part of the lecture.
Yeah, 5.2 to 5.6 or so. It kind of varies during the process a little bit. 5.2 is the low end, I think.
Yeah, that's a very, generally you're looking at your mash pH of 5.4 to 5.6.
Okay.
So it's all very well. You take your sample from your mash mixer, your meter shows 5.5. But you should standardize that meter with standard buffer solutions.
Right.
Every time you do a pH measure.
Yeah, I know that. I mean, I've only seen handheld units. I'm guessing that in commercial systems, there's an inline pH meter of some kind.
No. We used to you take a sample from your mash mixer, and you actually have a meter, a pH meter, and that pH meter is attached. It has two probes.
Right.
So what you do is you put your standard solutions. Make sure normally it's a standard solution pH 4, standard solution pH 7. Make sure that meter is actually reading that. Then you take your actual sample of mash and actually put the probes into that mash sample and measure it. But important, it's at 20 degrees you measure the actual pH. Okay. So, right. So we've now talked a bit about temperature, but we know now that we must check our temperature probes. We know pH. We must check our pH. We must check our meters before we actually measure it. So let's assume our pH is also okay.
Could I inject a question?
Absolutely. Please stop me.
I don't have a pH gauge of any kind. I've always relied on a product called pH 5.2. It's a It's a buffered a product. Is essentially you add a tablespoon of it per 5 gallons, and it takes the pH to 5.2, and it's buffered. So, it's 5.2 in particular, not 5.4 or 5.5. I've always assumed that 5.2 is the optimal, but I'm seeing it's a little bit higher from our lectures. Is this product just picking a 5.2 arbitrarily, or is it just off?
No, but you saying your water is 5.2, but once you've put your molten, and I'm assuming you're adding a bit of calcium, don't forget the calcium actually buffers, and you get calcium phosphate, and it can push the pH up slightly. I'm not saying 5.2 is radically wrong, but that's your water pH.
Okay, that's the strike water, right?
Yeah, your strike water pH. Absolutely.
Okay, that's probably what it is then. Yeah. Okay, thank you. Okay,
hopefully that answered your. Okay, so we've looked at that. We've already chatted a little bit about liquid to grist ratio. So with your liquid to grist ratio, there's, you've got water and malt or grist coming in. So how do you measure the volume of water?
By weight. I don't know. I'm guessing by weight.
I've never done it by weight. It's normally by a water meter.
Okay, flow meter.
Flow meter, yep.
Okay.
So, that flow meter, just like your temperature probe, needs to be calibrated.
Right.
Yeah, on a regular basis.
Right.
Okay, so we've looked at what could influence the actual problem starting at the mash mixer. But we've got all sorts of other things that happened before that, which I'll come to now. But I just want to make sure that we haven't skipped over anything that could be in the mash mixer that I haven't chatted about. So yeah, we've spoke about temperature probe, the water meter, and the etc. Okay. So now, okay, so we've established now. Hold on, very important thing. That's why I'll keep looking at my notes. How do you check for conversion in your mash mixer? Okay, normally, okay. Are you there?
Sorry, I'm muted. Sorry, refractometer.
No, there's a very simple way that it's used, and you use an N/10 iodine solution.
Oh, okay.
Okay. Some important things about that iodine solution. If you expose it to light, it tends to break down, and the age. So once you've made up an N/10 solution of iodine, you put it in a brown dropper bottle, and you cover that bottle in tin foil, and you keep it in the dark. You only bring it out when you actually are going to check your starch conversion. So the way you do it with that iodine is that you take a sample from your mash mixture, you put it on what's called a splash plate, a little bit of the mash liquid, and you put some drops of iodine. And if there's full conversion, it goes a yellow color. If you've got terrible conversion, and you put the iodine, it goes black.
Purple.
Yeah, in between is like dark red and brown. So that's the liquid should go yellow. Then you know you've got full conversion. Sort of, if you haven't had too good a conversion, brown, red, and if it goes black, you've got big problems, because then you've really had hardly any conversion. Okay, so that's a very important point. That if you are using iodine to check your conversion. Any questions around that, Michael?
Not really. It seems like they would want something more numerical as far as when they reached a certain level of conversion. But would a refractometer, would that work?
I've never, to be truthful, in my experience, we've always used a straight, simple iodine test.
Yeah. Okay. Yeah, I remember. Yeah, it certainly works on potatoes. So.
Yeah. Okay. So so we've established all those things we chatted about, the mash mixer. Let's assume everything is okay. So right, let's work backwards now. Okay. So what is the process before the mash mixer? What do you do to your malt before it gets into the mash mixer?
Mill it. Am I
right?
You mill it. Yeah.
Yeah, actually mill it. Okay. So now we've got, if you've established everything is okay in your mash mixer, the next step to go back to is obviously your mill. Right. So, and I've got two scenarios here. Let's start off with an actual 2 or 4 or 6 roller dry mill. So what issues with that mill could be causing you the problem of not converting or getting good conversion in your mash mixer?
Poor conversion. Well, inconsistent crush, where you have variable sizes of endosperm chunks, that could be caused by rollers out of adjustment, rollers damaged.
Absolutely.
And I suppose upstream from that, the consistency of the grain itself, of the malt itself coming into the mill, is sort of in there as well.
No, Absolutely, absolutely. So roller gap on a a steep condition and a dry mill is critical, and the roller gaps should be checked on at least once a week. Okay.
Could I throw in a question real quick?
Absolutely. Please throw in as many as you want.
Sure. In the again, all the homebrew supply stores where I would have the grain milled, the grooves would run not crossways to the rotation, but parallel to the rotation. So with grooves in them, so the barley grains would sort of line up in the grooves, but the pointed end would be pointing straight down and straight up, so that you follow. So the grooves were sort of pointing down into the crack of the joint of the two rollers, whereas the illustrations appeared to be that the grooves go across the rollers.
Yep. I call it longitudinal.
Yeah, longitudinal. Well,
yeah.
I swear I've seen mills where they're more they're not catching them across the grain. They're like, steering the grain straight down into the crush, where they seem like they don't get them across the husk. It's different. Do you see both kinds, or
No, well, the actual dry mills, the actual, what is the exact term now? I call it, the grooves are longitudinal. You've got to be very, very careful, and that is why when you check your roller gap, you've got to check it at both ends and in the middle, because funny enough, your wear tends to occur in the middle. So yeah, and
very interesting.
And just one other thing, that when you actually check it, a lot of people just put a actual feeler gauge in to say, well, you want 0.1 or 0.2 of a millimeter, but you should actually use a piece of copper wire and actually turn the actual roller when you're doing it, because if your bearings of those rollers are problematic, putting the copper through will actually push the rollers out. If you understand what I'm trying to say, with a feeler gauge, you push it up and it'll say, oh, well, that's fine, it's a 0.2. But when you put the copper wire through, if the roller bearings are problematic, the rollers will actually push apart, like exactly what's happening when you mill it.
Right. So you presume that copper wire would be larger than the gap you're checking for.
Yeah, absolutely.
Okay. Yeah. Makes sense. Makes sense.
Okay.
Yeah, Warren.
And okay, so with the dry mill, how do you know how do you know if your crush is okay? What analysis do you
do? I just really inspection really make sure the husks are intact and you have a really hopefully a consistent, well crushed endosperm.
Yeah, there is that, but you can also do an analysis where you actually take a sample. It's called a plant sifter analysis, where you've got a series of pans, and you put it on a shaker and shake it, and you need so much flour, so much of this grit, so much of that. It's actually in the lecture. So, once you go through the lecture, it's quite specific. It speaks about the plant sifter analysis. But you can inspect. Obviously, that's the first thing to do. Just have a quick look. If you've got whole kernels coming through, you got a problem.
I did notice the six row mills sort of segregate larger chunks and smaller chunks and sort of run the larger ones through again, so they end up with a very consistent size.
A 6-roller mill is an extremely flexible mill, because you've got 6 rollers. So and so with a 6-roller mill, you can actually manage to use, if your malt is slightly under modified, you can actually set your roller gaps, you know, to ensure that that you're actually getting the, and I'm not talking very undermodified, I'm talking slightly.
Well, the thing that those include, they have internal screens, if I understood
yes.
right. So presumably
Yeah.
your swatches, you're adjusting the rollers and the screens, or potentially could.
No, the screens are fixed. It's your actual rollers. So with a 6-roller mill, you can actually take a sample after the first set of rollers, second set, and the final set.
Right.
So you're actually setting your 3 sets each time. Okay. Hello?
Hello, I'm here.
Okay. Okay, so we spoke a bit there about actual dry milling. So let's now chat about the steep condition mill, because there's things there that you also have to control if you're using an intensive steeping mill or a steep condition mill. So once again, you've only got one set of rollers, so those roller gaps are critical. You've got to look after those. So I don't know, Michael, if you can hazard what else you're controlling in that with the intensive steeping mill.
I suppose before it hits the rollers, the amount of steeping, amount of water contact and duration, temperature. So how,
Absolutely.
I guess the idea is you want to avoid moistening the endosperm so it doesn't become gummy. You just want to moisten the husk. So everything involved in that time primarily, I guess. They mentioned steam that's being used. Wouldn't that heat the grain up more up to modification temperature early, or no?
No, it's generally water heated at a temperature of about 60 degrees. Okay. And your time that's exposed to is controlled very critically. So you're quite right. If it gets too moist, your moisture content coming out should be between 18 and 18 to 22%. So that occurs in that little chamber just above the steep roller.
Is that just for the husk or for the entire grain?
No, it's actually, you take your whole kernel. If you take the kernel and check the moisture, it should be between 18 and 22%. Okay. So you're actually moistening the actual the malt kernel.
I thought you were just moistening the husk, that you did not want to moisten the endosperm.
Yeah, the whole kernel should have a moisture content of about 18 to 22%.
Okay.
Now, remember we spoke briefly about the traditional wet mill, and that moisture content went up. You had to get that up to 28 to 32%. So that was extremely high. So, but with an intensive steep mill, you want your kernel to be 18 to 22%. If you go too high, as you said, you get very pasty, too pasty endosperm, and you could also shred the husk more because it's just too wet. Okay, so with that intensive steep mill, obviously the temperature of the water, it's controlled by a temperature probe that obviously needs to be calibrated, and also the volume of water coming in comes through a water meter that also needs to be calibrated to make sure that your temperature and the amount of water you're putting in is correct. Any questions, Michael?
No, this is, like I said, I haven't really used a mash mixer in my life. For me, it's just, you put the grain in a tub, you pour the water in. It's been pretty straightforward. Like, I'm gonna have to go look up mash mixers and get the idea. But how do you get the resulting grist from the mash mixer into the mash tun? You pump it?
Sorry, what was that question? I didn't quite get it.
Assuming there's still a mash tun where the hydrated grist goes from the mash mixer into a mash tun, or is that not used in this scenario?
Let's get this straight. A mash tun is the actual so with a mash tun, you actually put your molten water into a mash tun, and it doesn't have steam jackets. So you generally, with a mash tun, go in at 65 centigrade, and it sits there, and your conversion happens there. It's, the old mash tun is very traditional. I don't know if there's many commercial brewing companies that are using a traditional mash tun.
Okay, so the mash mixer is essentially replaced the mash tun.
Yes. So
okay, very good.
Yeah. Now let's chat a bit about it, because that's important. So your mash tun, and I know I've been corrected. We used to call them a mash tub, but since I've started doing this, I've learned. I think the actual craft brewers, and they call it a mash tun. We called it a mash tun. So the tun, you actually put your liquor and your malt into it. It generally doesn't have a mixer, and most of them you actually it has a false bottom, and you actually lauter there as well once the conversion has happened. But that's another whole subject on its own, the pros and cons of mash tuns and mash mixers. Generally, the mash mixer, as I said, has got a stirrer, it's got steam jackets, it's got temperature probes. If you've got, say, a very under-modified malt and you need some more proteolytic activity, you can actually go in there at a temperature for proteolysis of about between 45 and 48, have a stand there, then come up to 63, 64, and then up to 70, and then up to 76. So that's the difference between the mash tun and the mash mixer.
Okay, so following that, does it go to a lauter tun, or is that also done in the mash mixer?
From the mash mixer, or it can, if you've got a mash filter.
Or mash filter.
Because even if you've got a mash filter, you're still using a mash mixer before you get to the filter.
Okay, very good.
So your mash mixer comes before your lauter tun or your mash filter.
Okay, very good. I think I've got it.
Would you like to ask any more questions around that?
Nope, I think that part's I understand now.
Okay, I just want to make sure there's okay. So we've chatted now. We've chatted about the mash mixer itself. We've chatted about the mill. There is one bit of kit, and that's what the actual, if you in a actual a big brewery. So because when you, and I'm talking now if you're using a dry mill. So once you've milled with a dry mill at a big brewery, I'm not talking to a craft brewery, okay, then it generally goes into what's called a grist bin. So it actually sits in this grist bin, your milled malt, until you're ready to actually mash it. And it is imperative that that grist bin has generally a low level probe. So when you mash, it'll start to empty. It's taken by a conveyor into where the actual mash mixer is. It mixes with water, and once the grist bin is empty, it obviously stops. But if your low-level probe is faulty and you're left with stuff in your grist bin, you're not going to have the correct grist to liquor ratio in your mash mixer. So that's, you know, so looking, if you're in a bigger brewery where you actually have a grist bin, most important to check that probe and check it out on a set frequency.
Sounds like you've had some bad experiences along those lines.
Yes, yes. Believe me, I've had a few experiences with, you know, because what actually happens if your low-level probe fails and it stops, and generally the grist bin was a bit of a distance away from the actual where all this the max mixture was. So and so you'd mill again, and what would happen? It would obviously overfill, and there'd be a huge malt spill and all sorts. So yeah, I've experienced. Yeah, I experienced that that probe on the grist bin.
One thing they mentioned, I hadn't heard about a load cell. I guess is
yep.
Could you use that to could you use that to instead of a probe? Could you to know when it was empty by weight?
You could, no, but we just that's a very good question.
I guess it wouldn't be fine enough. The weight of the hopper would probably be so much larger than the weight of the last 5 pounds of grain, or where the last bit would be. You wouldn't be able to tell it probably.
You could actually, no, that's, you know, you could either use a low-level probe, or if you've got load cells and you've got 3,000 kilograms of grist and then it shows naught, you're quite right. So you could in fact use load cells, yes. But then those also have to be calibrated.
Calibrate the load cells.
Calibrate.
Oh, it's right there.
Calibrate pH meters. Calibrate temperature probes.
Yes.
You know. Okay. So now before the mill, we have another bit of kit. So you've got your malt silo. So now you've got your malt coming in. How much malt do you know? How do you make sure the right amount of malt is going into the brew?
Yeah,
how do you weigh it?
Scales.
Absolutely.
Dump scales, and what was the other one?
There's various types of scale.
Yes, yeah. One type is easier on the grain, and I've got it written down, but it's not on the tip of my tongue. But yeah, which have to be calibrated.
Absolutely. So we used to call them a tip scale. So that tip scale need to be calibrated, and we used to calibrate once a week because you know, most important that that tip scale was accurate. Okay, so now we spoke about the mash mixer, and we spoke about the grist bin, and then we spoke about the mills. We spoke about the scale. We found all those are okay. So what else now could be causing us this issue in the mash mixer?
I guess the incoming grain is about the only thing we haven't touched on.
Absolutely. Well done. The malt.
Inspection and all of that.
Okay, so if now we've established, Michael, that everything else is actually fine with this, with everything we spoke about. So what would, and we've been through this in one of the chats before. So what would you look at on your malt analysis to give you an indication if your malt's the issue?
I guess I mean, if you're experiencing a problem on brew day, that's one thing where you might check a different set of things than if you're than what you'd be checking when you received a shipment of malt.
Yeah, but Okay, so if we're looking at the malt now that we actually using, what would you look at on the analysis sheet to tell you if your malt could be giving this problem?
Is it friability? You know, that's one of the one
Okay,
which tells you the level of modification. It should tell you if you have some steely ends. Kind of it can tell you a lot from that one number, I gather.
Okay, no, you're quite right. So we could look at friability. What else? What else are you going to have a look at? Because don't forget what's from the malt is actually acting in the mash mixer.
Diastatic power.
Absolutely. So you look at your diastatic power, Windich Kolbach, and that gives you an indication of your obviously your alpha and your beta. And this, so we talk friability, we're talking Windich Kolbach or DP, diastatic power, and that is all coming back to modification of the malt. Okay, so if your malt has not been modified properly, this could be causing the issue because you're going to have low enzymes. But it could also be you could have germinated properly, as we said, but your kilning has been too harsh and destroyed a lot of those enzymes. So yeah, so looking at that malt analysis is absolutely vital. You know, especially if this problem's just started and you've had a malt change. I mean, theoretically you should have picked it up before you got to this stage, but you certainly, your raw material is obviously absolutely key. You know, if everything else we spoke about is okay. Okay. Do you want to ask any more questions around the malt?
Yeah. One thing that sort of keep mentioning is about oxygenation, or keeping dissolved oxygen out, but that's also important earlier in the process. In milling in particular, I kind of got the impression that you don't want to have the milled grain exposed to air for keep it as short as possible. You mentioned earlier a large brewery might mill a bunch of grain kind of in advance and put it into a hopper and then mix it, with in the mash mixer so it would be milled and dry in air for some length of time. Is that an issue? And I'm not really sure what's oxidizing in milled grain and how big of an issue that really is at a commercial scale.
That is an excellent point you brought up. We had a specification. Okay, and you are quite right that once you've milled into that grist bin, that grist had to be mashed within 2 hours.
2 hours, okay.
Because you're quite right, because the grist is exposed to oxygen, and believe it or not, it's oxidized. That is an extremely good point you brought up. No, so we had a specification, but because of 2 hours. So if it was 12 o'clock lunchtime, that had to be mashed by 2 o'clock in the afternoon. And before we started to actually work on all this, I remember when we never used to brew continuously, like when we stop on a Friday, start on a Monday, and I'm talking many years ago. I'm talking the 60s. We would mill for the first thing on Monday morning on the Friday, so you could quickly come in and start mashing in. So very good point. No, that is absolutely vital, that your grist needs to be mashed as soon as possible after it's milled.
So is it known what oxidizes in the grain? I mean, we really looked at what happens in the beer, all the things in stability and all that. What oxidizes in the grain, and what impact does that have on, I don't know, flavor, heading, etc.?
Yeah, you're looking.
Big question, I know, a huge question.
It's a big question, but certainly you do get, you know, oxidation processes occurring. You know, I just wanted to keep it as that's a whole topic on its own. You know, you do get oxidation processes because don't forget your malt has certain amount of reductones, which, you know, prevent flavor staling and that sort of thing. So yeah.
Okay.
Okay, but that was a very good question. And have you what we spoke about? Have you got any more things you'd like to ask? I'm just looking at my notes here.
Yeah. Well, I do have one big question, but it's definitely it's a home brewer question. So I was gonna
maybe absolutely
wait till the end of the hour and maybe try to hold you over.
No, well, we haven't got that long left, and so please ask it.
Well, it actually kind of, I noticed something at the very end of that, the handout from the next one, the function of enzymes. At the very end, it talks about extract, about malt extract. I've been a home brewer for 20 years, and 18 of it was all grain. But I find myself in a situation where I may need to do an extract batch or two. And I used to use, I guess most home brewers start out doing extract, and they go all grain. And I'm looking back, I'm not really sure what malt extract is, you know, from all of this perspective. Is the stuff you buy in a homebrew supply store, is that even intended for brewing? Is that meant for baking? And we're just sort of grabbing it. I understand it has to be boiled. So whatever they're doing, it's somehow they're getting the sugars out of the grain, but they're not boiling it. They're not heating it to isomerization.
Oh, so you're not actually using malt grist. You're actually using an extract.
That's, I guess, how, you know, you go into a homebrew supply store as a home brewer, you can get liquid malt extract, dried malt extract.
Okay.
This is how most home brewers start out rather than mashing.
Yep.
So this is, I mean, like I'm saying, this is so is very not really in the scope of this course at all. It's a home brewer question. But they talk about the end of this handout. It mentions the use of brewers using brewer syrups manufactured from hydrolyzed starch solution treated with exogenous enzymes, which sounds like it would end up with essentially what you get in a liquid malt extract at the homebrew supply store. It would have fermentable sugars, but it would not have been boiled. It would have all the proteins still in it, I guess. So,
yeah, you know, I haven't had really much experience, I'll be truthful, with extracts that are bought, you know, where you actually just have an extract and put your hops in. So I'm a bit, I haven't had that much experience, but I could help if you want to talk about extract in malt, like 76% as is or 81% dry, then I can answer your question. But I should imagine that with your homebrew kit, do they tell you your extract's got 76% extract, or is that what you're trying to ask me?
Yeah, fermentability. I kind of got the impression certain brands of extract had higher levels of dextrins than others. I lived in a place that I think had a malt plant nearby, and they got very fresh malt, and it seemed to produce a little bit fresher beer. But in hindsight, though, I think it developed the trans 2 nonanol really quickly. So I guess I'm just wondering, is malt extract made with oxygen in mind, yada yada. Yeah, it sounds like it's not something that really gets into the commercial brewing. So liquid versus dry malt extract, I guess, is same thing.
Yeah, I'm not that au fait with the extraction.
Yeah. But anyway, so that was the only other one that I had.
Okay.
Oh no, actually, I do have one more. Chain disc, moving crushed grain between mill and brew house. Chain disc, screw conveyor. There's something called a chain disc or a cable disc that pulls solid material like grains along in a pipe, but it may only be used for feed grain. Do you know what I'm talking about?
But we used to, our grist was moved from the grist bin with what was called a chain conveyor.
Okay, yeah, little discs or
No, it would be, I don't know how to describe it. It had horizontal pieces of metal, and it was like a chain, so it would pull it along. It's quite difficult to just describe how.
anyway, yeah, I'm just thinking
So
of
that was called a chain conveyor.
yeah. I was just trying to kind of mentally reconstruct something I saw at a small brewery in Portland, where the I guess the fellow was using some kind of screw conveyor and auger to bring milled grain up above his lauter tun, mash mixer, and then had hot water spraying on it as it was kind of coming out of the end of the auger. So it was just these blobs of hydrated grain were falling, a couple of feet down into the mash mixer. I thought, well, that's oxygenating it quite a bit, but I guess it all worked out, I guess. But yeah, anyway.
Yeah,
So he was using an auger of some kind. Yeah.
The actual mixes that I've experienced is it comes in with like your malt in one section, then your water, and then it's like vortexes to actually really get it wetted, so that in your mash tun you don't get clumping and big hard lumps of mash. That's because that's what you don't want in your mash mixer. Oh, and something that's something that we never I've never mentioned with the mash mixer, that you need to have a look, because if you've got, they call it balling, balling, and that is where you've got dry big balls of unwetted malt grist that actually float in your mash mixer. Oh, that's sorry, I forgot that bit.
Which gives you which reduces your efficiency, because water never touches it. Yeah,
absolutely. Anyway, that's about it. I've got no more. Is any more questions, or that's about it from this side? But I appreciate you. You've worked hard tonight. But anyway, thanks very much for joining.
Well, thank you, sir. It's always a pleasure. I'll see you next week.
Okay, thank you. Thanks very much. Thank you, Michael. I appreciate you joining. Thank you. And we'll see you next week. Yeah. Okay.
All right, very good. Bye-bye.
Bye.